Measuring angles. Objective: to find and compare the measure of angles. An angle is formed by two rays with the same endpoint. Okay. How to name it? You could say that it is angle A, or you could say, let me draw the picture first so that way you can see this. Here's my opposite rays, A, B, C. We could call this angle A. We could call this angle BAC. We could say this is angle CAB, or angle 1. Now the reason we like using numbers is that it's easy to reference. When you use the 3 points on the angle, you should be able to make that angle. So that center point should always be the vertex. So notice if I say angle CAB, I start here at CAB. I've made the angle. If I want to use angle BAC, I start at B. AC. Again, I've made the same angle. So when you're labeling your angles, it should be able to make the angle, and it's easy for the person to understand what angle you're talking about. The sides are rays of the angles. And this is a symbol for angles, so that way you don't have to write out angles each time. And so for our picture that we have here, our rays would be ray AB and ray AC. Those are the sides of our angles. And picture, you can say see above. Okay, the vertex, it's the endpoint. Okay, so this is point A, so we'd say point A. And when we redraw this, A, B, C, that's our vertex. Okay, interior. It's the region containing all of the points between the two sides of the angle. So, region containing, and we're not going to use this part on how to name it. There's not a specific name for it. So, containing all of the points between the two sides of the angle. Okay, and so a picture of that would be this part right here. That's the interior. The exterior is the region containing all points outside of the angle. And so again, if we have, here's our angle, all the stuff outside of it is the exterior. Example 1. It says, what are two other names for angle KML? So first I need to find that angle, so I have KML. Now with this one, let's see, I could name it angle 2, because if I'd say angle 2, it's obviously I'm talking about this angle here, so I could say angle 2. Or instead of going KML, I could say angle LMK. because that still makes up the angle. Now it asks, it says, would it be correct to name any of the angles angle M? Explain. Well, if I had called angle 2 angle M, could you be sure that I'm talking about angle 2? Or if I said angle M, could I be talking about angle 1? Or could I even be talking about angle JML? Anytime angles share a vertex, you have to be more specific when you're labeling them, because just saying angle M, your reader doesn't know which angle you're talking about. So make sure that you're specific. One way to measure the size of an angle is in degrees. A circle has 360 degrees. That should be sorry. So 1 degree is 1/360th of a circle. A protractor forms half a circle and measures 0 degrees to 180 degrees. Protractor Postulate. It says consider ray OB and a point A on the side of ray OB. Every ray of the form ray OA can be paired with one of the real numbers from 0 to 180. It says, what is the measure of angle AOB? How did you find it? So looking at your paper, we're trying to find the measure of this angle right here. Now when you lay something down on your protractor, you're lining up that center of your protractor with the vertex point. And you're going to line the 0 up with this side of your angle. Now sometimes they can come from the other side, but for this one it's lining up with this side. Now notice this is 0 degrees, so since this is 0 degrees right here, that means I start from the inside and start looking at my angles this way. So I'm coming all the way over here, and I'm going to read to see what it says. And so when I measure that angle, this one is going to be 125 degrees. Okay, an acute angle. An acute angle is between 0 and 90 degrees. And so we have a picture that looks something like this. A right angle, the angle measures exactly 90 degrees. And when you measure a right angle, to ensure that it's right, and I do mean a right angle, not as in form of correct, you have to have that symbol to say that it's perpendicular, that it's forming a right angle, so that way you're telling your reader that it is 90 degrees, not 89.9, but 90 degrees. And so this is our x degrees. An obtuse angle is between 90 and 180. And our straight angle is when the angle measure is 180 degrees, meaning it's a straight line. Example 2, it says use the diagram below, find the measure of each angle, then classify the angle as acute, right, obtuse, or straight. Okay, we're going to look at the first one. Angle BAE. So I need to find B. So here's BAE. So I'm measuring this angle right here. Now when I'm looking at this, on this one to get the zeros, the 0 is on the outside, so I'm using the outside marker, so I'm going to go all the way over. So this appears to be 110 degrees. And so if it's 110 degrees, it's greater than 90, so that means it's obtuse. Okay. The next one is angle DAB. AE. So I'm going to find D, A, and E. Now this one's a little bit different. On this one, we don't have one of the sides that go all the way to 0, so we're measuring this angle from here to here. Okay, well, this one was at, if I'm using the outside angles, this one was at 90, and this one was at 110. So if I want to find that angle measure, I'm going to take 110 minus 90, and I'm going to get 20 degrees. So that means it's acute. Angles with the same measure are congruent angles. And you'll see the symbol for congruent. Now, it says draw an example of this. Now, to indicate that they're congruent, I don't expect you to be perfect when drawing your angles. We'll call this angle A. We'll call this angle B. To indicate by the markings that they're congruent, you'll see a mark like that. If we have more than that, like let's say, let me do an obtuse angle over here. X and Y. So by those markings, I'm saying that angle X is congruent to angle Y, but it's not congruent to angle B. Example 3 says angle CBJ is congruent to what angle? So I need to find this angle CBJ right here. So notice there's 2 tick marks. So now I'm looking for the other one that has only 2, and I can see this right here. So I'm going to say it's going to be congruent to angle DHG. Part B says if the measure of angle EFD, so I need to go over and find angle if angle EFD, so I need to find that EFD. So if this angle is 75, says then what is the angle of JAP? So JA, and I think this should have been AP, by the way. Notice these angles are congruent to each other, so it would also be 75. They had a typo in their stuff. Or I had a typo, which is probably likely. Angle addition postulate. It says if point B is the interior of angle AOC, then that means that angle AOB plus angle BOC is equal to angle AOC. Example 4, last example. It says angle RQT is a straight angle. What are the measures of angle RQS and the measure of angle TQS? Now on this one, you might be sitting there going, I don't know any angle measures, but we do. We can see that when they say that angle RQT is a straight angle, that means it equals 180. So now I can set up the equation that says 6x plus 20 plus, so I have this angle, plus 2x plus 4, this angle right here, has to equal 180 because we already know that this is a straight angle. Okay, combining like terms, I have 8x plus 24 equals 180. Okay, so now I'm going to subtract 24 from both sides. So now I have 8x equals 156. Divide both sides by 8, and I get x equals 19.5. Now, again, that's not what the question asks. The question asks, what is the measure of angle RQS and the measure of TQS? So let's see. RQS right here, I'm going to take 2 times 19.5 plus 4. And when I take 2 times 19.5 plus 4, I get 43. So that means this angle is 43 degrees. And then over here, I'm going to take 6 times 19.5 plus 20. And I'm going to end up with 117 plus 20. I get 137. So this angle right here is 137 degrees.